Hey everybody, it's Mr. Canfield. So a bunch of people are absent. We got a test coming up. We had the snow day. So I'll just go through the review from start to finish. Okay. Is it possible to draw a parallelogram where all sides are congruent? If not, explain why it's not possible. So if you go look at like the hierarchy or the different choices we have, there's a bunch of options that make this true. So yes, we can. The ones that work where all sides are congruent, that's a rhombus. I said a bunch, it's two. A rhombus or a square are both a parallelogram where all the sides are equal. So, excuse me. So that's that. Let's see, number 2, complete the congruent statements for quadrilateral flip. So just remember that the order the letters are written matters. So when we see ISL, that order is going to matter here. So ISL going in that order. Well, the triangle that's going to be congruent to it is this other half of the bow tie up here. So ISL. So then we're going to want to kind of do the same format there. And if you can kind of see it, it's flipped in this one. So it'll be FSP. All right, let me see angle LFS. LFS, that's this angle here. And so if you remember how these work, there's that mirroring going on. So this angle down here is going to be the same. So I want to use the same ordering. So LFS. So end in the middle, end at the S, and that's in the, all right, okay, so what, PIS? And then SP goes from the middle to the out, so then SL goes from the middle to the out. Because remember that in a parallelogram, these get cut in half. The diagonals cut each other in half. So, all right. ABCD is a rhombus. So let's see, find the angle EBC. All right. Well, it's a rhombus, so I know the right angle, the diagonals cross at right angles and they cut each other in half. Oh, wait, well, they were just talking about angles anyway. The other trick though is that the corners are cut in half by, so like the fact that that's 34 means this is 34. Additionally, this guy and this guy are the same as this guy and this guy. And sorry if you can hear physics next door. They're having fun. So, oh, EBC. All right. Again, I'm getting ahead of myself. EBC. So that's that angle down there. That's a 34-degree angle. Now I want angle BAD. BAD. So these two pieces put together. Well, I can find one of them, right? Because we can just look at the triangle here. We know that's 34. We know that's 90. So we got 180 in the whole thing. We cut out the 90. We only have 90 left for these two. So 90 minus 34 is 56. So then we get 56, and that's also 56 because of the way this works. Well, 56, two of them together is 112. All right. Part C, this is an honors only part. So academic, if we saw this, it would just be a bonus question. And the way that we handle this, just a reminder. So again, you can skip this if you're academic, or if you want to see, that's fine too. And honors, I expect you know how to do this. So we know in a rhombus that all the sides on the outside are the same. Well, we just need to find one of them then and quadruple it. Well, we happen to have a very nice situation with these right triangles here. So we can do the Pythagorean theorem, 8 squared plus 6 squared is equal to c squared. So 8 squared is 64, 6 squared is 36, c squared is, we don't know yet. We know those add up to 100. So then we can take the squirt both sides and get c is 10. Well, hey, we got 10, so they're all 10. 10, 10, 10, 10, 40. So that's that one. Oh goodness, I should look at the camera when I'm writing. Sorry about that bottom part there, in case you missed it. So we added those up, and that was c squared. So we took the square root of both sides and got 10 is equal to c. I have filmed one of these in a while. Let me pay better attention from now on. All right. What is the most specific name that can be given to the quadrilateral shown below? So if we go look at our hierarchy, we have all these options. You know, there's, I see 2 parallel sides. I could call this a quadrilateral. Is there anything more specific? I don't have 2 sets of parallel sides though. I only have 1 set of parallel sides. So that immediately falls into the trapezoid camp or trapezoid family. And the little bit extra that we can do is, since these angles are equal, you know, that's saying these base angles are equal. Remember that when angles are equal in a shape, then the side opposing them is going to end up being equal too. So this and this, now we have those 2 equal sides. That is called an isosceles trapezoid. And remember, I don't grade on spelling. As long as I can figure out that you're trying to write those words, we're good. You know, if you try to spell isosceles with a W at the beginning, then I think we'd have something to worry about. But all right, which of the following is not a parallelogram? So a rectangle is a parallelogram. A kite is not a parallelogram, but a rhombus and a square are. So B. Very important with multiple choice questions like this to read and make sure you are finding out if it is the thing or not the thing and which one we're going for. Okay. I know in class I kind of rushed through some of these drawing ones, so I'll make sure I make this a little bit more clear. Let's see. Is it possible to draw a parallelogram where all sides are congruent? So a parallelogram, so we go look at the parallelogram family. And I've been talking about this, but I haven't actually pulled up an image of it, so let me just draw it real quick for you. We've got generic quadrilateral, right? So that's a triangle. Oh my goodness. All right. Hey, everybody. Generic quadrilateral. There. It's really hard to not. There we go. There. That's none of our. So we got our quad. And then the 2 options there, we have 1 set of parallel lines and you get a trapezoid. And then you have the 1 set of parallel lines and then the congruent sides that go with it. And this is the isosceles trapezoid. So that was the one side. Then we have the weird, we'll just put it over here, kite. And kites are kind of their own thing. You can turn a kite into a rhombus if you make the sides all the same, but we're just going to kind of basically leave that off on its own, and we're going to look at parallelograms. So in parallelograms, you know, we have the 2 sets of parallel sides, and then that led to the 2 options here. We had a rectangle and a rhombus. That's pretty good if I do say so myself. So the rectangle had the 90, you know what a rectangle is, and the rhombus was more like our diamond shape, and all the sides are equal to each other, but not at 90-degree angles. And then their child, the thing that has all 90-degree angles and the sides are all equal, is the super special square. So there's our square. So, and then secretly the kite can be connected to the rhombus, but we don't really talk about kites. So back to our example. Is it possible to draw a parallelogram where all sides are congruent? Well, okay, so parallelogram is all these, where all the sides are congruent? Sure, both of those. Oh wait, I'm so silly. This was question number 1. So hey, we already did question number 1, and we just did it again. But now I have this to refer to in future questions. Whoopsie. All right. Let's look at this one. Explain why the perimeter MNOP must be 22. So I see the two sets of parallel lines. So this is a parallelogram. So this is a parallelogram because two sets of parallel sides. So that's one point. And my next point is opposite sides of parallelograms. Trust me, I wrote the word parallelogram right there. I know it just looks like scribble, but it's absolutely parallelogram. Are congruent. So since MN is 4, PO is 4 and MP was 7, so NO is 7. So then 4 plus 4 plus 7 plus 7 equals 22. Hooray. All right, time for an honors only question. I will do the honors only questions at the end. Let's see, next one. In quadrilateral LONG, find these. Okay, well, in a parallelogram, remember that the opposite sides are equal to each other, and so are the opposite angles. So 72, 72. The other thing that's true is that everything adds up to 360, and because of that, 72 and this one, so L and G together, these are going to be supplementary, which means they add up to 180. So if I do 180 minus 72, I'll get whatever the heck that is. Let's see, 100, 108, okay, 108. And then since that's that, same logic happens down here. The opposite angles are true, so 108, 108, 72, 72. That should add up to 360. There you go. All right, so I've given these exact problems before. I am annoyed at myself that they're in the, whatever, that's fine. It's a square. Okay, well, it's a square. All the sides are equal. Everything's a right angle. So we might be tempted to say there's only 4 right angles. But the other thing is, in a rhombus, the diagonals intersect at right angles. And since the square is a rhombus, that means the diagonals of a square also intersect at a right angle. And normally you write a single right angle because if there's one, it fills the rest of them out. So because of that, I can say that's a right angle, and then that has to be, and then that has to be, and then that. So they all are right angles here. So there are 8 right angles in this diagram with a square. A rectangle is similar. We've got the 4 right angles here, except the diagonals do not intersect at a right angle. The thing about a rectangle that's different, or that's kind of unique, is that the 2 diagonals are the same length. In a rhombus, the diagonals don't have to be the same length, but in a rectangle, they do. So there's only 4 in this one. All right, quadrilateral HORN. Now, we're not 100% sure what this is going to look like, but the order that you write them matters. So however you draw a quadrilateral, so I could draw like that if I wanted to, and I could put H here if I wanted to, and then I can put O wherever I want to next to it. I can put O up here or over here. But now I've locked in HO. I got to keep going in that direction. So as long as they're in order, we're good. So it says R and H are the same angle. And it says O and N are the same angle. So which of these is the best classification? Well, it doesn't tell me they're 90s, so they don't have to be 90s. So it doesn't have to be a rectangle. In a trapezoid, the only special stuff we've seen in trapezoids is the base angles will be the same, but we don't actually get opposite angles are the same in a trapezoid. So it can't be that. In a parallelogram, this does happen. This creates 2 sets of parallel lines. So in a parallelogram, that's definitely possible square. So, and since they're not necessarily right angles again, we'd say it's not a square. So it could be a rectangle and it could be a square, but it specifically must be a parallelogram. And that's why we say parallelogram is the best classification. All right, now let's see if these are the things I skipped over a lot in class, and let me just make sure that I make sense out of them. Sketch and mark a rhombus with exactly one set of parallel sides, or explain why it's not possible. So a rhombus is by definition also a parallelogram. Parallelograms have two sets of parallel sides. There's no way around it. So it's impossible to draw something that's called a rhombus and still only, and it's impossible to be this rhombus and not be a parallelogram. So no, it's already a parallelogram. Dummy. Next, sketch and mark a quadrilateral with only one pair of congruent sides and 4 right angles. So the problem is, if we have 4 right angles, box, and we're trying to move these boxes around, the only way to do that and have a pair of congruent sides, no matter how you try to move these around and have them match up, you're going to end up having a rectangle with 2 sets of congruent sides. We're stuck, because the angles are like this, it's part of the parallelogram family, because the opposite angles are equal to each other. So this is stuck being a rectangle or a parallelogram. All right, 15. Sketch and mark a trapezoid with 1 pair of congruent sides and 2 pairs of congruent angles. So we talked earlier, we said we could have a set of congruent sides and then these base angles are the same. Well, let's see, is there any way for these two to be different? So I hope that you kind of see in this symmetrical picture that we're drawing, if these are the same, then these are going to have to be the same too. And there's a few ways that we could go about really making sure of this, but like, let's just maybe imagine for a minute. Imagine this is a 45-degree angle, and so then this is 45, and these are parallel. So if you remember 2 parallel lines cut by a transversal, which we can, there we go, okay. So that's this kind of situation where if I knew this is 45, then that's 45, then that's 45, then that's, like, we find all these, and the way that we find the other angles is we take 180 minus 45, which gets us 135 for all of these. So I hope that makes sense. Well, we can do the same kind of thing over here, right? We've got these 2 parallel lines. We have our transversal, and it's the same thing. This is 45, this is 45. This is going to end up being 135 again. There's no way for these 2 angles not to be equal if these 2 angles are equal. So, fancy schmancy. So just any old isosceles trapezoid. I don't, what is this, a squiggle rug? It looks like a magic carpet. Oh dear. Is that shape? I try to draw that shape again. Forgive me. Sketch and mark a quadrilateral with 2 pairs of congruent sides and 2 pairs of congruent angles. Yeah, guys, I'm filming a video if you don't mind. Yeah, I just said that in the video. That's great. Okay, sketch and mark a quadrilateral with 2 pairs of congruent sides and 2 pairs of congruent angles. 2 pairs of congruent sides. Oh, like that and that. 2 pairs of congruent angles, and then that and that That's one. Another one could just be any generic parallelogram, because the opposites in a parallelogram are equal. All right, most specific name we can give here, I really want this to be a square. I think it looks exactly like a square, but, wait, you know what? All right, so I'm gonna pretend that I don't know everything I know about the diagonals and stuff. We can still figure out what this is supposed to be, what this has to be. If you're just a normal parallelogram, or so there's something more going on here. So this is a right angle here. Those two are the same. That means these two angles have to be the same. This is an isosceles triangle. Well, 180 minus 90 is 90. And these have to add up to 90. So these are both half of 90. So these are 45s. And if you can see, that is going to happen in all of these. And these are all going to be 45-degree angles. All of a sudden, we have a bunch of congruent triangles where this side is congruent to that side, is congruent to that side, is congruent to that side. We have a square. So that's one way to show it. Another way is diagonals bisect. That's parallelogram. Diagonals are equal. That's a rectangle. And then diagonals are perpendicular. That's a rhombus. And the rectangle and the rhombus had a baby square. So that's another way that we can kind of arrive at the same conclusion. All right, circle all convex polygons. Remember, concave is when they cave in. So these are concave in, these are convex. All right, prove, we'll do that. And then ABCD is a rhombus. Mark the right angles in the figure. How many are there? Well, it's a rhombus. You know, all the sides are equal. We know these are right angles here, so there are the 4 right angles in the middle. We're not guaranteed these are right angles here, and hopefully it's pretty easy to see that they're probably not right angles in this one, so I got 4. All right, proof time. All right, I'm gonna try to prove this in as clear a way as I can. Prove that quadrilateral CART is a parallelogram. So the way that, and remember, this is an honors only thing. The way that we can show this, or the way that I have found to show this, or the way that I always see. There might be other ways. I'm not saying there aren't other ways. Like there might be something to do with showing angles. And anyway, don't worry about that. But that N shape here, that is, so ARS, I'm gonna use angle ARS, and then it's gonna be what, TCS? So I'm gonna using that angle ARS is congruent to TCS. They are alternate interior angles for AR and TC. Please just don't talk since I'm filming a video. Being cut by a transversal AT. In that situation, alternate interior angles are congruent only if the lines are parallel, proving AR is parallel to TC. This was super wordy to get there, but basically I had to recall this is called alternate interior angles when they're in this setup, and they're only congruent when it's parallel, so we know they're parallel. And similarly, RT is parallel to CA using its given pair of congruent alternate interior angles. Which were angle RTS and CAS. So CRAT has two sets of parallel lines, so it's a parallelogram by definition. Done. So that would be one way to prove this. Let me try to prove this in a less wordy way that still gets the same points across. So you could just say like ARS is congruent to TCS. That's given. Then you could say AR is parallel to CT because alternate interior angle theorem. I mean, you just say alternate interior angles. That's our kind of our shortcut word for that. And if you don't want to use like by the same logic the other two, so you could say like you could go right underneath it or right over it. I'm going to use a different color since I didn't plan ahead. And say angle STR and then angle SAC also given, and then so that tells me TR is parallel to CA. I guess AC. I should have written TRAC here. So now we got those and those, and then so CART is a parallelogram by the definition of parallelogram. By definition. So I wrote a box at the end of the last proof. You also can just write the word Q, or the letters QED. You can also just leave it blank and I'll know you're done. All right, so there's more than one way to prove these things. There's more than one logical path that will get you there. Okay, prove quadrilateral camp is a parallelogram. So I'm gonna do this the short way first and then we'll do it the longer way. And this time I think writing words is kind of faster. So opposite sides of a parallelogram are congruent. And that's given to us. So camp is one. This is such a dopey question. But it's, I mean, that we know that the opposite sides of a parallelogram are congruent. So, so another way that I would write this, since PM is congruent to AC, PC is congruent to AM, and parallelograms have opposite sides that are congruent. CAMP is a parallelogram. Since it's given that, maybe I'd insert that. Since it's given that this, and parallelograms of opposite sides are congruent, camp is a parallelogram. So there are other, like, if you don't remember that, if you don't see that, there's more that you could do. You could delve into the fact that we have shared sides here. And so then we have this shared side, and we have SSS congruency, which means that this angle and this angle are the same, and this angle and this angle are the same, and then this one and this one are the same. And now you've got these, like, and this are the same, and that's the same. So now parallelograms have opposite angles that are the same, so we're good. Or you could show, you know, we've got the parallel stuff going on like we did in that previous proof. Like, it's okay if you say all that. If you say all these different things, it's really up to what you see and how you're able to state it. So just make sure you end with, you know, camp is a parallelogram, or, you know, what we had earlier. So it's a parallelogram. You know, cart is two sets of, so cart is a parallelogram. You know, making sure to end with whatever conclusion they want you to end with. Make sure you end there. So if you go, I'll just say, no, I don't want to put it, I don't want to, oh man. I normally like to put a bonus in these videos, but I always do it at the end, and so if you're smart, you just go watch the end. So I guess I can't. Man, they're saying lots of bad words next door. Okay, bye.